Hello and Assalamu alaikum everyone. My name is Muhammad Arsalan Javed and I am a student of Master of Engineering Management program. This particular presentation is about an article named Lean and Green Supply Chain Management through Intermodal Transport, Insights from the FMCG Industry. This is basically an article presentation which we'll be going through in the next slide. This article is from the Journal of Production Planning and Control, published in 2017 in volume 28. The topic of this article is Lean and Green Supply Chain Management through Intermodal Transport, Insights from the Fast-Moving Consumer Goods Industry. This article is presented by three authors, Ms. Claudia and Mr. Alessandro, who are from the Logistics Institute from Hull University Business School, and Mr. Fabrizio Dellari, who is from LIUC University. All of the three authors are from Italy. This paper investigates how the intermodal transport can be adopted for managing the supply chains according to a lean and green approach. In this paper, there were two aspects. One of them was developing a scenario-based estimation tool, which was used to quantify the potential demand of intermodal transport. It was applied to the Italian fast-moving consumer goods supply chain. In the second part, there was a case study conducted on one of the FMCG company based in Italy, which was Procter Gamble, and the study was used to investigate the enabling factors for the adoption of intermodal transport. The results of the case study were promising and were actually able to and the results showed that there is a possibility to shift demand from road to rail in a number of pathways that were identified related to planning and management, assets, train services, collaborations, legal issues, and incentive schemes. A business model was also developed in order to highlight how exactly the modal shift can be done. Before we begin, there are a few terminologies which you need to know. What do we mean when we say lean and green supply chain management? It is basically a combination of two methodologies. One is the lean methodology. The lean methodology basically focuses on reducing the cost and waste activities within a process, while as the green methodology basically focuses on the environmental aspects, how green your practices are and how well they are connected and helping the environment. When you combine lean and green, you concurrently achieve the objectives of efficiency, effectiveness, and sustainability through lean and green. When we apply it in a supply chain management problem, this basically results in a new paradigm, which is basically known as lean and green supply chain management. This article basically focuses on the lean elements through achieving higher productivity and the green elements of supply chain by reducing the carbon dioxide emissions throughout their supply chain. So in this way, both the elements of lean and green elements were reaped within this case study. The second term which you need to know is what do we mean by intermodal means of transportation of goods. The word intermodal transport means basically using a combination of two or more different modes of transport where the load is transported in one and at the same time to the other intermodal means of transport, with most of the route traveled by rail, inland waterway, and ocean shipping. The advantage of intermodal transportation, or the objective of intermodal transportation, is to reduce the carbon dioxide emissions related to the movement of goods along the supply chain. In this study, the railroad modes of transportation were investigated together while addressing its challenges. Now that you know what is intermodal transportation, we are going to discuss about the challenges to the intermodal transportation. The author discusses how intermodal transport is usable for non-time sensitive products when moved in sufficient distances in sufficient quantities with balanced flows in both directions and when assets can be well utilized. The very first challenge in adopting the intermodal transportation is basically the operational and quality factors. These factors revolve around the operational sustainability of adopting the intermodal transportation. They basically focus on, for example, transit times, how far, how slow, the supply chain is. This intermodal transportation method is how fast or how slow. What is the reliability? How flexible this system is going to be? And what about the order visibility, safety from the damage? Is this mode intermodal is safe for the product itself? And how well it is utilizing the assets of the company, and what exactly is the break-even distance justifying the use of the modal transportation. So these are the factors which are covered in the first factor of operational and quality in the intermodal transportation. The second challenge is related to the product itself, which is being transported by adopting the intermodal methods of transportation. It basically focuses on the suitability of the products for intermodal transport. It focuses on the attributes of the product itself, for example, the worth of that product or the product value, product demand, what is the size of the product, what is the weight of the product, is it compatible with the intermodal transportation that we are adopting, and what exactly is the perishability of the product. This is one of the most important factors under the product factor, that is the product non-perishable or is it perishable. Why? Because for example, if you are transporting something which is refrigerated and in the train you don't have that facility, that particular product is going to basically expire. Why? Because of the conditions. So you need to know exactly what kind of product is suitable for being transported by the methods of intermodal transportation. The third factor is the supply chain management related factors, which is also a big challenge for those who will adopt the intermodal transportation. Now, if you are adopting an intermodal method, you have to plan accordingly. You have to set delivery windows, how fast you can deliver goods from one place of origin to the destination, what will be the likely process of ordering, and what will be the likely process of the logistics. This needs to be considered to ensure consistency of decision making along the supply chain. There is a strong interdependency of the modal choice decisions on different levels in a supply chain context, which cannot be made in isolation. So these are the main three challenges that were identified when someone or a company chooses the intermodal transportation methods for transporting its goods. Now comes the part of what is the research question of this particular article and what is the methodology which was used in order to answer the question. Now the question is, how is it possible to make the modal shift from road to rail feasible by connecting the supply and demand of intermodal transport along the supply chain? So you need to understand that the intermodal transport is basically focusing on shifting the road network and combining it with the rail network. So there will be a combination of road and rail network in this particular article. Now, in order to explore the possibility of making this modal shift from road to rail, there were two methods or approaches which were used. The first one is a quantitative approach, which is basically the authors designed a scenario-based estimation tool which provide a quantification of the potential demand for intermodal transport. This basically focuses on how many freight movements are basically moving from road to rail, and this particular tool takes into consideration some of the leading Italian FMCGs which are present in Italy and have the highest freight movement or the heaviest freight movement throughout Italy. Secondly, there is a case study on an actual company which was conducted in order to gain results. This actual case study spans a duration of 2 years, and it was performed to investigate the challenges and the enabling factors in adoption of the intermodal transport. This particular fast-moving consumer goods industry is no one but Procter Gamble company, which volunteered for this analysis. The very first thing that was done was to create a scenario-based estimation tool. Now, how this scenario-based estimation tool works is basically the first thing is that you input some data into this tool. There is a point regarding the development of a collated project database. It was developed by gathering data from Italian companies that constitute for about 10% of the road freight movements. Now, in order to create a collated database of freight movements, you need to know that it is in terms of basically road shipments. The input data must also include the location of the intermodal terminals considered as hubs of origin and destination of the potential intermodal flows. Data then needs to be georeferenced through a geographical information system to associate the geographical coordinates to each single point of origin and destination of the flows. The georeferencing of the road freight was done by identifying the 9 heaviest areas where there is the heaviest flow of road traffic. Now, this is basically when then the algorithm of this estimation tool processes it by applying various parameters and results in an output. Now, the output of the algorithm is the number of freight movements in each origin to destination region, that is the catchment area of the hubs, and that can be potentially shifted from road to rail each week, and this is expressed in intermodal loading units, ILUs. As an outcome, the most relevant origin to destination relations were identified. Now, this ILUs is basically nothing but a shipment, a single transportation or a single freight movement. So ILU basically stands for one freight movement from one origin to the destination. Now, the first application of the estimation tool was only used to cover the road networks. This is the first scenario which was processed through the estimation tool, and the result that it gave was 714 ILUs per week, which is basically 714 shipments per week, which have 26 origin to destination relations. What we mean by 26 origin to destination relation is basically 26 total number of the origin destination and the final destination where the product is going to be disposed of. Now, in this scenario, the result that we obtained was 714 shipments per week, which corresponds to 35,000 shipments per year, and it corresponds to 22% of the overall freight movements included in the project database. Now, why does it cover 22% of the overall freight movements? Is because, as we have mentioned earlier, that the total database that contains the record of 10% of the Italian FMCGs. That is the reason that it corresponds to 22% of the overall freight movements. In the top left corner, you need to also consider the parameters for this result. You need to know that the lead time is 1 day for this particular scenario, and the minimum distance covered is 350 kilometers. What we mean by lead time is that each shipment will only be moved with a constraint of 1 day. It needs to be disposed of or reach its destination within 1 day. And the minimum distance that this shipment should be covering is of 350 kilometers. It has to travel a 350 kilometer distance in order to reach its destination. So these are the parameters which were used in order to generate results of 714 ILU per week or 26 origin to destination relations. As you can also observe, the top 5 transportations or the shipment movements was from Pomezia to Milano with about 71 ILUs per week, which is closely followed by the shipment movements from Nola to Catania, which is corresponding to 60 ILUs per week, which further, if you go on from Bologna to Nola, 54, and Novara to Pomezia at about 50 ILUs per week. So these were the highest 5 cities where the freight movement was highest per week. One of the features of this estimation tool is its ability to carry out the sensitivity analysis on the acquired data. Now, you need to understand the parameters, and you need to understand this estimation tool is basically used to adjust these parameters and to check how does that impact on the number of shipments per week or the number of ILUs per week. Now the parameters, as we know, is one of them is the lead time, second is the radius catchment area in kilometers, and third one is the distance in kilometers. The radius catchment area is basically the movement through the road network, and the minimum distance is basically through the rail network. So you need to know and understand the radius catchment area is slightly different than the minimum distance. The minimum distance, as you know, is basically covering from city to city distance, and the radius catchment area basically covers after the product reaches the city and it goes to its destination. So from the city or wherever the storage area is where it is reaching, and then it is further going to its destination, that is the catchment area. Now, looking at figure A, you need to understand that the value of the minimum distance is kept fixed at 350 kilometers. So one of the parameters, which is the minimum distance, is fixed at 350 kilometers. Now, the idea here is basically varying the lead time, which is basically up to 3 days, and the catchment area radius is changed from 60 up to 150 kilometers. So the sensitivity analysis is done basically by keeping the minimum distance constant at 350 and changing the lead time through 1, 2, 3 up to 3 days, and changing the catchment area from 60 up to 150 kilometers. Now if you look at figure B, you will realize that if you relax the lead time constraint, it imposes a greater positive effect on the number of ILUs. So basically, if you increase the lead time of basically moving the goods, it increases the number of ILUs, which is the number of shipments. But this effect is still less than to potentially be shifted than the one obtainable by relaxing the constraint on the radius of the catchment area. Now, if you look at figure C, it depicts the effects of changes in the minimum distance from origin to destination, taking a fixed value of the minimum lead time, that is of 1 day. Looking at the sensitivity analysis data, you can see that only 110 ILU per week were obtained when you keep the radius catchment area to 60 with a lead time of 3 days. But slowly the number of ILUs increases to 416 ILUs per week when you increase the catchment area to 90 and reduce the lead time to 2 days. So they have a negative correlation between them. Now, if you further increase the catchment area to 150 kilometers and lead time of 1 day, and remember we are keeping the minimum distance of 350 kilometers, then the ILUs that we got from the estimation tool is 1330 ILUs per week. This basically means that since the city to city distance is constant, and if we keep the minimum distance city to city distance at 350 kilometers, if you increase the radius of the catchment area, it will have a very positive influence on the number of ILUs per week, and keeping the lead time at minimum, which is 1 day, which is very good for the companies. Now that we are done with the road transportation and creating scenario and the sensitivity analysis based on the road transportation only, this is the second scenario, which basically is taking a percentage split between the rail segment length and the overall travel distance equal or greater than 80% and a minimum lead time equal to 1 day. What we mean by is this, that the travel distance is 80% through rail. So 80% of the distance is traveled by rail using the rail segment, and 20% of the distance is traveled through road. So this is where we are testing the intermodal method of transportation, that is taking the 80% consideration of the rail network and 20% consideration of the road network. Now, in this scenario, when the estimation tool was run, it generated the result as 1056 ILUs per week, which corresponds to 52,800 ILUs per year and to the 33% of the overall freight movements included in the project database. Now, if you see, it also includes 35 origin to destination relations, which means that it has a higher coverage than the road network. So if you use a hybrid system or the intermodal system, you can cover about 1056 shipment movements per week, and you increase the origin and destination relations by using the road and rail network. Here you need to understand there is a limitation. The limitation is basically that the shortest origin to destination relations are disadvantaged, whereas the longest one present a greater potential. What we mean is higher or longer the distance is from origin to destination, the better for the adoption of intermodal transport. So intermodal transport is going to be beneficial when there is a span of a longer distance. So if the cities are very far, this is where there will be more benefit of adopting the intermodal system. But if the cities are very close by, let's say 200 kilometers or 100 kilometers, then this is a disadvantage if you use the intermodal method, that is, you use the train or the rail and the road network. So these results are very close to the road network. But again, if we employ the rails, that means you are going to significantly reduce the carbon dioxide emissions used through road network. So now that we have all the scenarios, the first scenario, which is employing only the road network, and the second scenario which have a split with 80% distance covered through rail and 20% covered through road. Now we are going to actually apply um, how exactly this happens in the real scenario. You have to test your results, and this is what the second part of this article is going to be done. Now that we have the estimation tool give us good results of this, we are going to test it through a case study. You have to realize that the authors basically have to convince the multinational called Procter and Gamble company, which is basically an American multinational consumer goods corporation headquartered in Ohio and founded in 1837 by William Procter and James Gamble. I think most of us are familiar with the name of Procter and Gamble and its FMCG sector, which is popular throughout the world. So Procter and Gamble was approached by these authors of this article, and they were able to convince the company to be a part of their case study investigations. They will apply their knowledge into a real scenario. One more thing which you need to know is basically what are fast moving consumer goods. They are the products that are sold quickly and at a relatively low cost. Examples include, like for example, non-durable household goods such as packaged food, beverages, toiletries, over-the-counter drugs, and other consumables. So nothing perishable. You understand there is a limitation that you cannot transport perishable goods. So most of the goods which are non-perishable are going to be used in this case study investigation. Now, the pilot implementation test was conducted from July 2013 until April 2015, which basically means 2 years duration for this particular case study. It was conducted by using the intermodal transport to deliver consumer goods along the Italian FMCG supply chain. It basically utilized the train and road system of Italy. During the period, data collection was done by means of templates, questionnaires, recording of patterns in a case template, through workshops, etc. All the details related by the destination and the origin and all the location through georeferencing was fed into the scenario-based estimation tool for further analysis. Now, the idea here is, did it give results? Yes, it gives positive results, and this is what we are going to cover in the next slide. Now you need to realize that the scenario-based tool, the results of the two presented scenarios, which was earlier, the scenario 1 if you remember, which is the covering the road network, and scenario 2 where it covers the road and rail network. Both of them show the existence of a potential demand for intermodal transport in the FMCG supply chain in Italy and identify a series of promising origin to destination relations. The potential demand was derived from a database containing only 10% of the overall Italian FMCG flows. Consequently, the overall actual demand for intermodal transport would be even much greater than the actual. Now, looking at the pilot test report or the results of the pilot test report that was conducted on the Procter and Gamble FMCG of the Italian company, it's an Italian company. The average difference between the all-road delivery cost and the road rail intermodal transport delivery cost was of 50 euros per ILU. That means the company was saving about 50 euros per shipment if it employs a road to rail network rather than all road network. So you see, there is a part of lean implementation where you are saving cost and reducing your waste. Obviously, for any company, the main idea here is to increase its profits, and employing the road rail system, the road rail intermodal transport system, the company was able to save 50 euros per shipment. Imagine the magnitude of savings that a company can make if it has thousands of shipments going all around the country. The second thing, which is again the very important aspect of logistics, is the delivery time, or the percentage of delivery completion. All the companies are focusing on the promise that they are going to cover the delivery within the promised duration. As you can see, the results were very near to the all road option. The all road option basically gave us 98%, that 98% of the deliveries were completed within the agreed time, compared to 96% of the deliveries which were covered through road and rail network intermodal transport. So 96% against 98%. I guess it's a close bet, and if you further enhance your system for employing road and rail network, this 96% can match 98 or even 99%, similar to the all road option. So this also signifies that it will not significantly impact the percentage of deliveries completed within the agreed time window. Now comes the third factor, which is the green part of this investigation. The average carbon dioxide emission percentage difference between the all-road delivery option and road rail intermodal transport delivery option is 30%. That means there will be 30% less carbon dioxide emissions if you employ the intermodal transport delivery method, which is basically road and rail network combined. It will save you 30% or 30% less carbon dioxide emissions compared to the all road delivery option. So imagine how positively and how nice it would be that a company is contributing, not just it is completing its deliveries, but it is also employing a method which help reduce the carbon footprint on the world. You all know global warming is going on, and if the companies are serious about doing a task and contributing their role of saving the world, intermodal transport is one of the ways that they can use to reduce the carbon dioxide emissions and impact positively on the whole world. Now, during this pilot implementation test with Procter & Gamble, the article authors basically identified 6 enabling factors for which were necessary for the modal shift from road to rail network. And these include planning and management, the assets, obviously, the train services, supply chain collaboration, legal issues, and incentive schemes. So these are the 6 factors which are going to be handled, or which are required to be handled by the companies in order to employ the intermodal transportation method. The planning and management is the first factor. As you can see, planning and management, the current situation is that we have a rigid order to delivery cycle in especially the FMCG industry, where the order size decisions are taken regardless of the constraints, and there is a highly variable and unbalanced bidirectional flows of the within the areas from origin to destination. The ideal situation that the article they were able to employ was to share overlap of implementation and mechanisms in the supply chain and in the transport operations. Diffused alignment of order size decision with intermodal transport constraints will be the ideal solution to handle this problem. Second is the assets. In assets, the current situation indicates that there is a limited compatibility of intermodal transport systems and operations within the FMCG flows, and there is limited availability of the shipments and the trailers. So the ideal scenario would be that there will be diffused visibility on the logistics flows across the supply chain with a high quality and reliable intermodal operations. There needs to be development of quality assurance procedures and communication with shippers in order to effectively utilize the assets. The third factor is the train services. Obviously, if you are employing the rail network in your consideration, you have to look at the limited availability of the train services. You have to think about the train schedules. You have to align your deliveries based on the rail schedules or the train schedules. So ideally, wide availability of dedicated freight train services needs to be done, which obviously if a government is going to be involved, they will provide these freight train facilities to the companies who are willing to adopt the intermodal transportation method. The fourth factor is the supply chain collaboration. Obviously, within a supply chain, many of the FMCG industries are involved, so they need to be more flexible with each other. There should be industrial initiatives for collaboration with academic community, government, and the trade associations. And there is a requirement for horizontal and vertical collaboration so that everyone can reap the benefits of intermodal transportation within the supply chain. The fifth factor is the legal issues. This obviously can be removed by industrial initiatives in collaboration with academic community and the trade associations. So this can be resolved if there is any issue. And last but not the least are the incentive schemes. There is currently limited funding available for the startup for intermodal initiatives, and there is limited incentives for ongoing intermodal transportation methods. So in order to ideally handle the situation is that the European Union and the national governments basically fund these kind of initiatives. Fair European Union and national regulations should be present in order to cover the road rate transportation, or for example, if they tax the road transportation, many of the companies are going to go towards rail, which is going to be taxed less, so they can save cost in the taxing as well. Now, as a presenter, I am going to provide you with some practical implications related to adopting the intermodal transportation. The first one is the increased complexity of the supply chain scheduling. The logistics will not just going to cover the road transport but also needs to consider the train schedules. Both the train schedules and road transportations are required to be synchronized and matched together. So the process becomes more time critical when you adopt intermodal transportation. So this is one of the practical implications of adopting intermodal transportation. The second one is the increased utilization of rail network leading to higher shipments per week. This indicates the potential for capacity expansion with increased utilization of assets. This means that the process is more lean. That means that it is saving cost and it is helping to increase the capacity of the company without actually increasing its own potential. It is employing a method which has itself a lot of potential to increase the capacity. The third implication is decreased carbon footprint in terms of decreased production of carbon dioxide, making the process greener. So the green part of this of adopting intermodal transportation is that the companies are going to produce less carbon dioxide by adopting this intermodal method. One of the limitations of intermodal transportation, however, is that it is only applicable for perishable goods. As it was mentioned earlier, you have the non-perishable goods such as cosmetics can be covered only, which doesn't require special conditions for storage. This marks the end of my presentation. Thank you for hearing me out. Bye bye.